Welcome to Ask and Learn.
Okay, so for this problem, we are asked to determine how many different isomers there are for C3H8, C5H12, and C6H14. So for the first one, which is C3H8, we know that all of the C's have a degree of 4 and the H's have a degree of 1. So what that means is that all of the carbons can have 4 places to where they bond. Hydrogens only have 1. So if we're going to do C3, let's think about all the different combinations we could have. And because there's only 3, they can really only be in a straight line. Because even if we do this, they're still in a chain. Okay? So this one, there's only one isomer. For part B, C5H12. So we have a chain option. So that's the first one. Another option that we have is to have 4 in a row and to have one of the other carbons on any of these. It doesn't really matter exactly which one, but it is going to be on one of the internal ones. We can't have it on one of the ends because that would be a chain again. And then our third option is to have 3 and to have 1 on either side of the middle. So to have kind of a T or a plus sign. So this one's going to have 3 isomers. And then for our last one, we have C6H14. So obviously the first one we have is a chain. So that's our first one. And then our next one, we want to have 5 in a row. So 5 carbons in the chain. And the first one was that would be right across the middle. So this one has to be the middle. The other 5 option would be for it to be on a non-middle. So it could either be on this one or it could be on this one. Because if it's on one of the ends, again, it becomes a 6 carbon chain. And then our next options are 4 carbon chain. And we could have the carbons on the same side. Or we could have a 4 carbon with them being on different sides, whether it could be here or it could be here. But regardless, they're going to be on different sides. Okay, and it doesn't really matter. So total, there are now 5 isomers. If we do 3 on 3, that would be a little bit, that would actually be not functionable for this particular